In this lesson, we shall focus on mathematics, MAT141 calculus UKZN, rights, improper integrals, and a lot more. Right. This is part 4, the beginning of it. Obviously, I mean, the objective is to review. This was the easiest of questions we did because we let f be a function whose second derivative is continuous on the closed interval from -1 to 1. Use integration by parts to show that. So we looked at this, and the trick was to remember integration by parts. U to v equals uv minus the integral of v du. This constitutes integration by parts. This is the formula. At this point, you let u be equal to. So at this point, you need to let u must be the thing that can be differentiated, and such that if it's differentiated, it disappears, and v must be that particular entity which, when integrated, vanishes as well. So now at this point, we actually find the derivative of u with respect to x. The u dx is 1, so which means the u is equal to dx. We find the integral of this, meaning v, for instance, is going to be what? If you integrate f double primed, it's going to be f primed, because by integration, you are removing the derivative there. Okay, right. So now what we're going to do, we need to first find the integral, and then we'll plug in the limits of integration. So we therefore have the integral of x f double primed that dx equals u. What is u? U is x. V is this one. So in other words, you would put the u, which is x, v, which is f primed of x, minus the integral of v, which is f primed of x, du equals exactly dx. Okay. And at this point, you're able to see that this is f, x f primed minus. Now we integrate this one. The integral of the f primed of x becomes exactly f of x. Okay, we're good. Now at this point, we actually can see that we have the integral. We can plug in the limits of integration from -1 f x double primed x dx. And this is x, this minus f of x, -1 to 1. Okay, you plug in everything, which is 1, right, which is exactly that. Okay, which is exactly 1, f primed of 1. Right, so you have f primed of 1, etc. Okay, right? F primed of 1 minus, you plug in. Okay, you substitute 1, 1, 1. Then you minus, then you substitute what? You substitute -1. So in the place of this x, there's going to be a minus, but there's going to be f primed of -1 minus f of -1, like so. Right. And then when you check this out, it's going to be f primed of 1 minus f of 1 plus f primed of -1 plus f of -1. Check this out. How does this compare? We can see what we have. Like there's f primed of 1, and then there is minus f of 1. We can see f primed of 1 minus f of 1, and then we can see f primed of -1, and then we can also see plus f of -1. So this one we've been able to achieve. In other words, we concur with the claim by the person who wrote this chart that this one here is actually, we have the f primed of 1, yeah? We have the f primed of 1, and then we plus f primed of what? F primed of -1. Yeah. Okay, let me check your chart. Right. Okay. Okay, that's fine. 2f. Okay, that's fine. I'm suggesting we do 2f. So we're going to actually do 2f just now. Good. And then obviously we have minus f of minus 1 plus f of minus 1. Okay, let us look at 2f. We look at 2f. We look at 2f. Right, good. So, right, I need to make sure you are referring to that one. So, indeed, you're suggesting that we look at what? Right, can you please start at number 2f? Right, so let us look at 2f. Now, to deal with 2f, we need to, because this one is quadratic under the square root, we need to use what we call completing the square. So we have 15 minus 2x minus x squared, which is exactly x squared plus 2x minus 15. And this is minus. Okay, so we must always make sure the coefficient of x squared is 1. So you must factor out the common factor. And then now you have x squared plus 2. Yes, please.
When do you know when to complete the square?
Okay, always when we have this, anything under the square root as a quadratic under the square root, you need to complete the square all the time. Right, because if you do not complete the square, then there's no way these can be integrated. So we need to complete the square. So that therefore becomes very important. So then we have x plus 1. You square this, and then this is minus 1, which is minus 16. Okay. So then in the end, okay, yeah, now we have completed the square. But if we multiply through, and then we have 16x plus 1 squared, right? So we multiply through by the negative, and negative by negative becomes plus 16 that. Okay, so now we get to this. So to integrate these, we must integrate this. So we must integrate 16 minus x plus 1 squared. Okay, there are instances where you need to complete the square pretty much all the time. But there are instances where you don't need to go, it's not necessary to complete the square. Like how? If somebody can give you like, even a number like 12 minus x squared, should you complete the square here? It's already a square, this. Because this thing must always be like a difference of 2 squares or a sum of 2 squares. That's what we want. But now, if there is an x term, then you need to complete the square. Even if there's a question we did last time where we saw something like this. We might have been doing the arc length or whatever. But even if you have 2x minus x squared, 2x minus x squared, this one, because if you let u, right, if you let u to be this cannot be integrated. Otherwise, it is trigonometric substitution that you need. But there is a term, you see, this thing must be a difference of 2 squares. Like this is it's a square, and the 16 it's 4 squared. So this one you must also do the same. You must complete the square because there's no other way. Right? There's no way you can let u to be minus x squared. It's not going to cancel with anything outside the square root. So you must complete the square. But you see, there are instances where even if you have, yeah, this one, you must also, here, you can't complete the square. It's already in the form you want, and you can actually be in a position to do everything you need. Okay, right. Now, this one can be integrated with so much ease if only we let x plus 1 be the square root of 16. The sine of theta. Okay, so you always let the x plus 1 be the square root of this. But the square root of 16, you already know. It's a 4 sine theta. Okay, so what can help us is doing the full TATS. So the truth is, time is often too short. What we need to do, we need to do the full TATS and then go to the textbook also. Then you'll understand everything. Right, and then now we find the derivative of this. Derivative of this, of the dx, and then the derivative of the sine is the cosine, theta d theta. Right, so you come here and then you get the integral of this, which is exactly 16 minus. So you have the x plus 1, this one. Okay, the x plus 1 is 4 sine theta. So you put 4. Okay, there is a dx here. Yeah? Okay, and then here you have sine theta like this. And then you square this. Yeah? You square, because it's x plus 1 squared. So you have that squared. What is the x? It's 4 cosine theta. D theta. Yeah? So that in the end, yeah, you have this one is 16. 4 squared is 16. So you factor out the 16. You factor out the 16, it becomes 4. Under the square root, you have 1 minus sine squared. 1 minus sine squared theta. Then you have 4 cosine theta d theta. What is 1 minus sine squared? 1 minus sine squared is cosine squared. Right, so it's rather, yeah, 1 minus sine squared is cosine squared. Then what is the square root of cosine squared? Square root of cosine squared is cosine theta. But there's a 4 times 4, which is going to give us 16. Cosine squared theta d theta. Now we're here, and then we need to just remember a little bit of high school, double integrals. Right, the high school taught us that if whenever you have cosine 2 theta, it is the same as 2 cosine squared theta minus 1. Yeah? So which means that we need to make cosine squared the subject here. Cosine squared, which is cosine 2 theta plus 1, you divide by 2. Like I indicated, the best way to learn this is to do the TARTS plus the textbook questions on this topic. Because the TARTS don't have everything. They just have some jump questions, but they at least have the key parts you need to know. Okay, so you can pull out the 16 here. And then what is the cosine squared? The cosine squared is actually cosine 2 theta plus 1, which you divide by what? By 2 d theta. Let us find the integral of this. What is the integral of this? Now, first, to find the integral of this, we need to have 16 divided by 2, which gives us 8. The integral of cosine 2 theta plus 1 d theta, which is 8. What is the integral of this now? The integral of this one is half the sine. The integral of the cosine is half the sine of 2 theta. Check this out. So it becomes half the sine of 2 theta plus c. Okay, this is already the answer, but we must change it back to x. Okay, we must change it back to x. To change it back to x, you use the triangle. So in other words, we have already said that whenever you have the integral of 15 minus twice x minus x squared, as I said, learning and mastery will come when you do all the TART questions, and then not only the TART, we do the TART plus the textbook problems on these. Then everything is going to be very obvious, because this is very, very easy. Right, then you have the x plus 1, who remember is 4 sine theta. Right, so now we need to use the triangle, because we get to this point. And now the triangle is always used to change the things back to the original variable, because everything was in terms of x, but we just changed things to functions of theta. But now at this point, we want to find sine theta. So sine theta is x plus 1, you divide by 4. So if this one is theta here, the sine using SOHCAHTOA, the sine is opposite of hypotenuse. So opposite theta, hypotenuse is 4, right? And then at this point, what then are we able to achieve? We're able to then say that we just need to get this side here. What is this side here? because it's advisable to find all the sides of the triangle. So this one is going to be the square of the hypotenuse, which is 16 minus, is the hypotenuse squared minus the other side, like this, by Pythagoras theorem, right? So at this point, then you move to this side. Half of 8 is 4 sine 2 theta plus 8 theta plus c. Okay, what is sine 2 theta? Is 2 sine theta cosine theta. 8 theta plus c. 4 times 2 is 8. What is the sine of theta? Yeah, sine theta is x plus 4. X plus 1, excuse, out of 4. Okay, and then we have cosine theta. What is cosine theta? We come to this triangle, and you get it from the triangle. What is cosine theta? In view of SOHCAHTOA, cosine is adjacent of hypotenuse. You have the triangle. Adjacent of hypotenuse is this one out of 4. But again, this thing here, you can even write it like this, because we've written it as 16 minus that, but we know that it is exactly the same as what? It is exactly the same as 15 minus double x minus x squared. So we already know this. So the cosine is adjacent of hypotenuse, which is exactly the square root of this. 15 minus 2x minus x squared. A yard out of 4. Okay, which is adjacent of hypotenuse, yeah? And then plus 8. What is theta? Right, we need to find theta here. So theta is obtained from this. If sine theta is this, then it means that theta is arc sine of x plus 1 out of 4. Yeah, theta is arc sine of x plus 1 out of 4. Okay. Right. So that we have 4 by 4, 16. 8 out of 16, 1/2. X plus 1, the square root. 2x minus x squared. Plus 8 arc sine of x plus 1 out of 4. Plus c. So this becomes the answer. This becomes the answer. This becomes the answer. Think about it and ask if you have questions. Yeah, but this looks like exactly the answer that is there. So you need to check in the chart and see. But I'm just taking in the chart to make sure that it is the answer that is cited there. Right, it is the answer that is cited there. And this one is chart 4. Okay, and then we shall move to G. G is exactly the same, but the problem, the difference with G is that G is the x squared is coming first. It does not have a negative in front, but it has a 9. So that is the difference. But we can do that with so much ease and great simplicity. So yeah, it's we got the answer to F, and then let us look at G now. Okay, if you look at G, G is like this. But once again, we need to make sure that every tart question is understood. Okay, so what do we need to do here? What do we need to do? We need to complete the square, because there is an x term. If there was 9x squared and minus 8, no need to complete the square. That one is already what we want. But at this point, we need to complete the square. Let us just complete the square together. So to complete the square, we're going to have 9x squared plus 6x minus 8. Factor out the 9. And then have x squared plus. If factor out the 9, it becomes 6 out of 9. 2 out of 3. X. 8 out of 9. Which is exactly x squared plus 2 out of 3x. Plus 1/2 2 out of 3. Like that. Minus 1/2 2 out of 3. Minus 8 out of 9. Okay, so you cancel this. X plus 1/3. You square this. Which is x plus 1/3. So you cancel this now, getting x plus 1/3. You square this minus. You cancel this, which is the 1/3, and then you square this. It becomes 1 out of 9. Minus 8 out of 9. X plus 1/3. Minus 9 out of 9, which is minus 1. Okay? And therefore, now you can multiply through. Okay, this is okay. It's okay like this. Perfect like this. So in other words, now if you want to do this integral here, it is the same as in the bottom. You're going to have this one. Right, you're going to have exactly this. Going to have exactly x plus 1/3 minus 1 dx. Okay, then you take the square root of 9, which is 3. So you're going to take out the 1/3 and have dx over the square root of x plus 1/3, you square it, minus 1 dx. Next, what do you do? Because the x term is first, you're going to let x plus 1/3 be equal to what? Let x plus 1/3, because it is first, it must become the sec. Must become the sec of theta. Not only because it is first, but it is first minus 1. Because if it were first plus 1, then you're going to use the tan. At this point, it means that dx is what? This one is sec tan d theta, which is 1/3. What is dx? Sec theta, tan theta, d theta. That is the x. It is divided by. Now you come to the bottom. So you have the x plus 1/3, which is sec. So this thing is going to be exactly sec squared theta minus 1. Yeah. Okay, why did you not put anything here? Here we put the square root of this number of 1. But the square root of 1 is 1. Okay. So you get this. At this point, this is 1/3. The integral of. What is sec tan? You'll have sec tan d theta. And then you divide by the square root of this. What is sec squared minus 1? Sec squared minus 1. So this one, sec squared minus 1, you need to remember from school. Sine squared theta, cosine squared theta equals 1. You divide by what? By cosine squared. So you'd have sine squared theta, you divide by cosine squared plus 1, and then you divide by cosine squared, which is tan squared plus 1 is sec squared theta. Yeah? So that sec squared minus 1 is tan squared. Sec squared minus 1 is tan squared. The square root of tan squared is tan theta. This gives us 1/3 the integral. The tan cancels, giving us 1/3 of secant of theta d theta like this. Okay. Now, at this point, what then are we able to achieve here in G? So this means that Very nice and short little problem. So now you then have 1/3. The integral of this one. What is the integral of this one? Is the ln. The integral of the secant is the ln of sec theta tan theta. Okay, plus c. 1/3 of the ln. What is the secant? Okay, because we already know that secant of theta is x plus 1/3. So which means that in the place of this, you can put x plus 1/3, but also can write it as a 3x plus 1 this. Okay, according to the way they wrote it, 3x plus 1 out of 3. Okay, that's how they wrote it. Plus tan theta. What is tan theta? Okay. Now we just need the tan theta. Tan theta is easy. Tan theta, according to this, it's going to be sec squared minus 1 square root. In other words, from this, if we want to find the tan theta, we can use the triangles, yeah? But now we can also do it differently, because from this identity, you can write sec squared minus 1. And then now the sec squared minus 1 is the same as what? So the sec squared minus 1 is this, yeah? And then you can find the square root here of the sec squared minus 1. The sec is this one. X plus 1/3, you square this. Minus 1. Like that. Like that. Okay, plus c. Like this. Okay, this is already the answer, but you can write the way they wrote it. For example, you can actually come and then say, whenever you have the integral of dx, nine x squared plus 6x minus 8 dx is 1/3 of the ln right. Okay. Okay, we continue, please, yeah? So we've already said it's going to be 3x plus 1 out of 3. Okay, we continue. Okay, sorry. Let's see. Okay, yeah, maybe it's the network. It is my hope that we are very clear because we're experiencing load reduction at the moment. So the network, it is our hope that is okay. But yeah, we're experiencing load reduction. So this is plus the square root of the secant squared, which is x plus 1/3. You square it minus 1. Yeah? And then you add c like this. But this is 1/3 the ln, 3x plus 1 out of 3 plus, then you can write this x plus 1/3 like the way that they wrote, because I want to make sure the thing looks like exactly what they've given there. So this is 3 pi x, which is actually 3x plus 1, and then you square this minus. But if you then will have a 9 here, so there's going to be a 9. And then the 3 squared is going to be 9, whose square root is going to be 3. Something like that. So yeah, you're going to have exactly that answer. Okay, yeah, we continue. Okay, yeah, I hope that our network is very perfect because of the load reduction in the area. Okay, let's see. Let me see. Okay, that's fine. Right, yeah, because maybe it might have an effect on you that we're experiencing load reduction in the area. So you see, by virtue of the load reduction, the network might not be the best, but yeah, it's just load reduction this morning, and then you're gonna be okay. Right. Okay, we continue. So now let us look at the next one. Once again, this thing is recorded. So the discussion is recorded. Whenever it is recorded, then you'd have like enough things. Okay, let's look at number 3. Let's do number 3. In number 3, it's very nice and easy. You need to show that arc sine x is the ln of this for all x. Okay, first, yeah. Now let us prove this one. This one is very easy to prove. So to prove this one, you let y be arc sine. Okay, so you let y be arc sine of x. If y is arc sine of x, then you can move the hyperbolic arc sine to the left, giving us exactly the hyperbolic arc sine of y equals x, which means you have the hyperbolic sine of y, which is e to the y minus e to the minus y divided by 2. Divided by 2 equals x, which is e to the y minus e to the minus y equals double x. Multiply both left and right by e to the y. Right, so you're going to have e to the y minus e to the minus y. You multiply it by e to the y, you have 2x, you multiply by e to the y. E to the y squared. 2x e to the y. Which means you have e to the 2y minus 2x e to the y minus 1 equals 0. So that there in the end, you need to find the square root of this. Quadratic, which means that e to the y is 2x plus or minus the square root of the following. B squared, so it's going to be this squared, giving us exactly 4x squared minus 4ac, which is plus 4, all over twice a is 1. A is 1. Meaning that you have e to the y is equal to, you divide 2x by 2, you get x plus or minus. And then you have the square root of 4, which is 2x squared plus 1. Which is e to the y, it's x plus or minus that. Okay, yeah, you get this. The exponential function here is positive, so the e must be positive, so which means that your e to the y would have to be x plus, so that you can ensure positivity, because this is positive with the plus in the middle. It will always be positive because the exponential function is always positive, so this will always be positive. And then you solve for y, you take the ln, both sides, and this means y equals the ln of x plus the square root of x squared plus 1. Okay, And then what is y? Y is arc sine, which is the ln of x plus x squared plus 1. So we've been able to show that the arc hyperbolic sine is the red equation. So it is the arc hyperbolic sine is actually equal to the ln of this. And then we are sure, therefore, that that is what we get as the answer. That is what we get as the answer. So you need to check this out. Right. So at this point, then we continue to do the other things. As I said, that it is our hope that we are very clear because of the load reduction in the area. It might maybe impact the quality of the communication. So it's something that you need to be aware of. So we continue. So we continue. We continue. Right. So continuing, we have a couple of things that are important. Let's go on. Okay. Now, also, you can prove the cosh. So, for example, the cosh is the ln of x plus the square root. Okay, so now we need to prove this. And to prove this, we'll to prove that arc cosine is arc cosh is that one, arc hyperbolic cosine, right? We can let the arc hyperbolic cosh to be y. And at this point, you then have what? You then have that this is the same as what? X equals cosh y. Cosh is e to the y plus e to the minus y out of 2. Which is 2x is e to the y plus e to the minus y, which is e to the y plus e to the y minus y. So that 2x is e to the y equals e to the y plus 1. Right? We multiplied both sides by e to the y. And then which means that you have e to the y, which is square. Okay. Yes, my brother. Yeah, I'm actually finishing a morning class now. I did not forget about you. So let me get back to you immediately after my class so that we can discuss the issue because I know you're stressed up, my brother. Okay. Plus 1 equals, yes, my brother. Yeah, but after my class, I'll get back to you. Okay. This is e to the that. Okay, thanks, my brother. E to the y squared minus 2x e to the y. Okay, so now you'd have the 2x e to the y, you move it across, and then you'd have that. So, which means there's e to the y equals, okay, so you use the quadratic formula. So it's going to be minus b. There's already a minus, so it's going to be 2x plus or minus the square root of the b squared, which is the minus 2x squared. It becomes 4x squared minus 4ac divided by 2a, which is 2x out of 2. And then take the square root of 4, it's 2x squared minus 1 out of 2. Which is x plus or minus the square root. This. Which means it is e to the y equals x plus the square root. Right, then you need to solve for what? We need to solve for y. Right, take the ln both sides so that y equals the ln of x plus the square root of x squared minus 1. Right? And upon careful examination, what are we able to see here? We're able to see that what then this is going to do okay, check this out. Okay, what is the y? Y is arc cos x. So this is one is going to be arc cos x is equal to the ln of x plus the square root of x squared minus 1. Okay. So this is what we get. This is what we get. This is what we get. So let's move on to the next question. Okay. Evaluate using the trigonometric substitution. And this is the hyperbolic substitution. Which is dx divided by the square root of 9x squared plus 1. Right, and so to evaluate this particular integral, what exactly do we do here? It's the same like we did, but here we're going to use the arctan, okay? But use trigonometric substitution in the first one, and then in the next one, we're going to use the hyperbolic substitution, this one, right? Yes. By dint of that, yeah. So now let's continue. We're going to use first trigonometric because it's 9x squared plus. So we're going to use the 10. We're going to use exactly the 10. But to use the 10, then we need to write this one as, because there's a 9 in front of the x. So you can do a lot of things. But one of the easiest we can do is to put the 9 also under the square, like this. At this point, we let the 3x be actually the square root of the 1. You can write some of these things so that you can remember that we're not just writing 10 here, because you're the student. It is the square root of this number. And then you put 10 theta. What is theta? So this is the case, yeah? And then, yeah, we can do a couple of things. But let us do this one. It's very easy. So what you're going to do is, for instance, when this is the case, when 3x is the 10, what is 3dx? The derivative of the 10 is the sec squared, theta d theta, yeah? Dx is equal to sec squared theta d theta out of 3. Now, blue color. It means that you'd have the integral of what is dx? And then you have 1 divided by, what is 3x? It is the 10 theta, but you square it. which is tan squared theta plus 1. What is dx? Sec squared theta d theta out of 3. So that you have the integral of, what is tan squared theta plus 1? It is a sec squared. Sec squared. So the square root of sec squared is sec theta. So this is 1 over sec theta. And then the square root of, and then you have the sec squared here. D theta. But there's a 3 here like this. So sec theta d theta. Okay, the integral of the sec is what? Plus tan theta. Yeah. Okay, sec theta. What is sec theta? So now we need to use the triangles. Let's use some triangles here. So using some triangles, put the theta here. Then you're gonna have like tan theta. Tan theta is what? Okay, draw a triangle here. It's okay. Like this. So that this one is theta. Yeah. If that is the case, what then we're able to do? So this is theta, and therefore tan theta, you use SOHCAHTOA. You use SOHCAHTOA. So the tangent is opposite of adjacent. Opposite theta over adjacent. So it's opposite of adjacent means it's a 1 here because it's over 1 this. Then you need to get the hypotenuse, which is exactly this squared plus this squared square root. Okay, so if you square a 3x, you get 9x squared. You add the 1, you put a square root like this. So that now the secant of theta, you go back to the triangle like this. What is the secant of theta? The secant of theta becomes the reciprocal of the cosine, which is in view of the Chaucher-Cow. Right, Chaucher-Cow. So that now the cosine is adjacent of hypotenuse, but the secant is hypotenuse of adjacent. Hypotenuse is the square root of 9x squared plus 1. Right, is the square root of 9x squared plus 1? This is exactly 9x squared. Which is 9x squared plus 1. Okay, let me write clearly here. Okay, let me just write clearly here. So this is exactly 9x squared plus 1. Right. So the secant is hypotenuse over adjacent. So hypotenuse over adjacent theta is just that. Out of 1. So the 1 doesn't change anything. Yeah, can leave it. Can leave the 1. Plus the tangent of theta. What is tan theta? Tan theta is 3x. And then you add c like that. That's the answer. So, okay. We continue. We continue. We continue. Right. Right. Okay, we continue. Yeah? So check this out and see if you have a question, then we can proceed to the next thing. Like I indicated, All right. Okay, let's take a break. I think let's take a break because your network is problematic, right? Your network is very, very problematic. So let's do this. Let us take a break. Let us take a break. Okay, we're going to take a break and we're going to be right back. Let's take a break and we're going to be right back.